Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential problem. Make sure to stick to the end of the video where I have a bonus problem for you guys to solve as well. Alright, so we have 1000 squared minus 999 squared. And I actually have two methods to solving this problem. So the first method is, well, we start with 1000 squared minus 999 squared, and then 999, this is the same thing as 1000 minus 1. So now I'm going to replace 999 with 1000 minus 1. So now I have 1000 squared minus 1000 minus 1 squared. Now, if I have something in the form a minus b squared, if I have something in the form a minus b squared, this is equal to a squared minus 2ab plus b squared. So in this case, a is equal to 1000 and b is equal to 1. So this is going to equal 1000 squared minus 1000 squared minus 2 times 1000 times 1 plus 1 squared. And now this is equal to 1000 squared minus 1000 squared plus 2000 minus 1. Now 1000 squared and 1000 squared, these two will cancel out, so all I'm left with is 2000 minus 1, which is equal to 1999. Now, my second method to solving this problem, well, we again start with 1000 squared minus 999 squared. And now, last time I said I replaced 999 with 1000 minus 1. This time I'm going to replace 1000 with 999 plus 1. So now I have 999 plus 1 squared minus 999 squared. Now, if I have something in the form a plus b squared, this is equal to a squared plus 2ab plus b squared. So in this case, a is equal to 999 and b is equal to 1. So this would be 999 squared plus 2 times 999 times 1 plus 1 squared. And then I have my minus 999 squared at the end. Now this is equal to, these two will cancel out, so I'll be left with 2 times 999 times 1 plus 1 squared. Now 2 times 999 is 1998, so I have 1998 plus 1. And this is equal to 1999. Alright, so I have 3111 squared plus 2889 squared. Now the first thing I'm going to do is I'm going to rewrite this as 3000 plus 111 squared plus 3000 minus 111 squared. Now I'm going to set a equal to 3000 and I'm going to set b equal to 111. So now, if I substitute these in, I get a plus b squared plus a minus b squared. Now, a plus b squared, this is equal to a squared plus 2ab plus b squared. and a minus b squared, this is equal to a squared minus 2ab plus b squared. So now, if I add these two together, I get a squared plus 2ab plus b squared plus a squared minus 2ab plus b squared. So first off, these two will cancel out, and I'll be left with a squared plus b squared plus a squared plus b squared, which is equal to 2a squared plus 2b squared. Now if I factor out 2 from this, I get 2 times a squared plus b squared. Now remember how we set a equal to 3,000 and b equal to 111. So now if I substitute these values back into here, I get 2 times a squared, so 3,000 squared, plus b squared, so 111 squared. Now 3,000 squared, this is the same thing as 3,000 times 3,000, right? And you may think this is hard because it's a 4-digit number times a 4-digit number, but we can actually for now ignore the zeros and we could just do 3 times 3. So that would give us 9, right? And then we simply add all the zeros after. So we're going to add 1, 2, 3, 4, 5, 6 zeros. So 1, 2, 3, 4, 5, 6 zeros. So our answer here is going to be 9 million. So now I have 2 times 9 million plus 111 squared. Now for 111 squared, this is equal to 111 times 111. Now, if we try to do this, 1 times 1 is 1, 1, 1, 1, 1, 1, 1, 1, 1. So I have 1, 2, 3, 2, 1, which is our answer. Now, 9 million plus 12,321 is going to be 9 million, 2 times 9012321. And this is going to equal 18,024,642. So this is our answer. Guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential equation. So we have e to the power of x plus 3 is equal to e to the power of 3 plus e to the power of x. Now, if we have something in the form a to the power of m plus n, this can be written as a to the power of m times a to the power of n. So as you can see right here, we have e to the power of x plus 3. I'm actually going to rewrite this as e to the power of x times e to the power of 3. And now this is equal to e to the power of 3 plus e to the power of x. Now I'm actually going to subtract e to the power of x on both sides. So now we get e to the power of x times e to the power of 3 minus e to the power of x is equal to e to the power of 3. So now if I factor out e to the power of x, we get e to the power of x times e to the power of 3, because e to the power of x times e to the power of 3 divided by e to the power of x is simply just e to the power of 3 minus e to the power of x divided by e to the power of x is 1. This is equal to e to the power of 3. Now I'm going to divide by e to the power of 3 minus 1 on both sides. These two cancel out, and we get e to the power of x is equal to e to the power of 3 over e to the power of 3 minus 1. Now I'm actually going to take the ln of both sides, because the natural log, or ln, is the inverse, or the opposite of e, meaning those two would cancel out. So if I take ln on both sides, get ln e to the power of x is equal to ln e to the power of 3 over e to the power of 3 minus 1. And if we take the ln of e, these two would actually cancel out, and we would simply just be left with our exponent, which in this case is x. So it would be, we would have x is equal to ln e to the power of 3 over e to the power of 3 minus 1. So this is our answer.